Over the last century, the population of the world has quadrupled from 1.8 billion people in 1915 to 7.8 billion people in 2021, and we may reach 9.7 billion by 2050. With rising population, the demand for housing space and food has also increased exponentially. But agricultural land is only reducing, and the size of landholding has been reduced to small pockets. Food demand is expected to increase anywhere between 59% to 98% by 2050. However, the ecological and social trade-offs of clearing more land for agriculture are often high. Solution: go vertical, because necessity is the mother of inventions. In a world where technology is moving so fast that majority of people are finding it difficult to keep up, the basic issues like food security still remain a core policy concern. So how would the future of farming look like? Will technology make farming more sustainable? Will the robots make farm labor redundant? Will artificial intelligence grow our food? In our quest to find out the most advanced and futuristic farming techniques, the one that had the most wow factor was vertical farming. Not only farm labor, vertical farming is making even the most basic ingredients of farming like soil and water redundant. For decades, vertical farming was just a fiction shown in sci-fi movies. But today, vertical farming is fast becoming a mainstream idea. Let's see how it's done. Vertical farming involves stacking layers of crops vertically in controlled environments to optimize plant growth. There are three processes usually adopted in the vertical farming systems: hydroponics, aeroponics, and aquaponics. In a hydroponic system, plants are grown in nutrient solutions free of soil. The plant roots are submerged in a grow tray containing nutrient solution. The excess solution returns back to the reservoir and is pumped back during the next cycle. In aeroponics, plant roots are suspended in the air and periodically sprayed with nutrient solution. This is the most efficient vertical farming process as it uses 90% less water than hydroponics and also requires lesser nutrients, but on the other hand gives about 75% higher yields. Aquaponics combines aquaculture and hydroponics. The fish present in the fish tank produce waste that is high in nutrients. This is then fed to the plant roots in the grow tray. The bacteria present in the grow tray fixes ammonia into nitrates. Plants in turn filter out the water, which is fed back to the fish tank. Unlike traditional farming that relies on Mother Nature, vertical farming relies on CEA technology, that is Controlled Environment Agriculture. With this approach, elements of the environment in which the plants grow, like light, temperature, humidity, and nutrients, are artificially controlled to suit the plant's needs. Vertical farms use LED lights instead of sunlight. Cameras and sensors carefully monitor the growth of the crops. The end goal of vertical farming is to produce the most possible crops with the least possible space. The population growth along with rising incomes in developing countries is causing dietary changes such as eating more protein and meat. This is driving up the global food demand. Vertical farming is beneficial in multiple ways. It promises a much higher yield than traditional farming. It is easier to produce organic crops in such a controlled environment. Pesticides will not be needed to protect the plants. Farmers will be safer as there is less heavy machinery and exposure to bugs and pesticides. The plants are grown without herbicides, fungicides, or insecticides. The climate change-driven water scarcity, rising global temperatures, and extreme weather will have severe long-term effects on crop yields. But because the environment in which plants grow in vertical farming is very controlled, farming can happen year-round and is not dependent on seasons and weather. Droughts, heat waves, storms will not be a problem with vertical farming. People are becoming more and more urban, with the vast majority of humans living in populated areas. Vertical farming allows humans to be prepared for the future with continued population growth and increased movement to cities. Vertical farming can potentially use 95% less water than traditional farming. Using less water means less of a toll on the environment and dwindling water supply. They can also reduce the negative environmental impacts from overstressing resources, preventing groundwater depletion and the destruction of fertile lands through overuse of fertilizers. But for all the benefits of vertical farming, there are some limitations. The costs of building materials and operating costs are high. This kind of hyper-controlled indoor agriculture requires an expensive labor force of engineers, plant scientists, and computer programmers. Vertical farming also relies on urban real estate, which is more expensive than rural farmland. Unlike traditional farming, which relies on insects for pollination, vertical farming relies on manual pollination. This process is long and expensive as well. High-tech agriculture is still high risk because there's no soil or other barrier to protect the roots. Even a small amount of bacteria or mold in the root chamber can harm the plants. And any breakdown in the system, like a pump or sprinkler, can kill the crop. Traditional in-ground agriculture will continue to produce the vast majority of our staple crops in the decades ahead. Vertical farms, though, can play a key role in producing local and perishable specialty crops. Feeding an ever-growing population in a feasible, affordable, and sustainable way is one of the potentially largest problems human civilization will face in the future. Vertical farming may be the answer for which everyone is looking. Vertical farming is sustainable, uses less space and water than traditional farming, and it is not dependent on the weather. With more research and funding, vertical farming might become the new norm.